Hey, what's up, people? Alright, here we go. 10:14. Timer set. Let's do this. Okay. So many things in my things to do. Okay, so we stopped here. And this is inclined refactor. We know it was a hard DC if it wasn't a soft DC and it was a reconnect. Implies we need to add in code that ensures database is cleared whenever a game is finished so we don't errantly assume we are reconnecting. Yeah, that is true. I do need to add that. So let's put the things to do. So what we have here. Let's see. Okay, so this is if selected choice is equal to start a new game, elif selected choice is equal to reconnect. So this is if we do a reconnect, then um, we do all this stuff, which is what are we doing here exactly? This is loading in the client ID, game ID, local or remote. And then we assign the client and the related data here to get everything rolling with this client script. We set the Pygame video mode, and then we say if client soft disconnect is equal to false and client is reconnect is equal to true. And only in that case would we run setup. And this only needs to be run for a hard disconnect. Soft DC would already have this data applied. I think it would retain 100% of it. Okay. So, yeah. If soft disconnect is equal to false, and client is reconnect is equal to true. So let's see. Client soft disconnect. Okay, so all that's coded correctly. But we need to create this client is reconnect. So the associated logic for this. This doesn't actually exist. So let's put a bookmark there. Sure, we are resetting this back to false or whatever if properly saving this to database considering whether save restored. Sure, proper game logic overall. proximity exists is equal to 0. Not a reconnect, else. Okay, so I need to finish this. Need to create this adder, and also is here allowed to use determine if we need to run setup function in below section. Need to ensure we are resetting this back to false or whatever if needed, and properly saving this to database considering whether it should be saved, restored, etc. to ensure proper. Yes, so we need to create this adder. We also need to do this. So let's go over here. Ensure we're resetting this back to false, and this is called client is reconnect. I don't think we would need to save this to the database because we just use game ID, but to determine that. So I don't think we need to save. But we do need to create it. So what is it called? Is reconnect, so that would be in the I. And this is a bool. we'll just leave it default to false, and yeah, just let it be default to false. Yeah, I think that'll do what we need it to do. So we may need to create a new feature branch or creation of server refactor to work with without damaging current server PI structure, because it involves refactoring functions such as start accepting clients and associated delicate logic. Do this before reapplying all their save game data to let other client know ASAP that client has reconnected.
This would be a good time to test the power of my perfect form. Oh, Goku. I've so longed to fight. Don't think for a moment that you're the only one that has changed. Beat it! Take your planet with you! Kamehameha! You're finished. You think a barrier will work?
Okay. So this is the hard part. Here we go. Alright, so now it's if client soft disconnect is equal to false and is reconnect is equal to true, that means there's a hard disconnect. Then we run the setup, but now we know it's a reconnect, so we need to use the game ID to reconnect to the proper game. But currently its server is not coded in such a way that will allow us to have more than one game. We coded in the game ID transfer, but it has no connection and no logic. Like it has nothing inside of it that would actually allow us to have a second game run at the same time. I was thinking we could have another script to run, another server script to run, but that's not the way that you do this. You scale your server script to handle more clients. So the way that this would be accomplished is not easily. So what we're gonna do, we're gonna have to create a new file for this. We're gonna save this server as we're gonna make a new one called server refactor. So now we have a client refactor and a server refactor file. So there we go. Server is still preserved, exactly the same. We just have another file here called server refactor. That's where we're going to be working. We're not going to be working from server anymore. We're going to be from server refactor. Main try, necessary trigger logs, exceptions. Alright, so we need to basically just start at the top. Like, what do we need to do in this refactor? What is the goal here with the refactor? Well, it's to allow for more games to be run, and which implies more threading, more processes. If name is equal to main, try custom logger setup. So when setup is run, this might imply having to refactor a lot. I think we would probably want to use a new process instead of a new thread, because we're not going to need access to these data points. Like, we basically want to replicate the server side functionality and a game is started and we have all these assignments for player 1 and player 2 and client 1 and client 2. we're gonna reuse that same exact language. It's gonna be the exact same code, as a matter of fact. We just have to like run it in its own environment. Not environment, that's not the proper programming term I'm looking for. The one I'm looking for is more like, I guess you would say, process, to where we have a completely different set of card IDs. We have a completely different client 1 and client 2. It's the same language, but according to, you know, this process, whatever we call it, this next thread, it wouldn't be a thread, it would be a process. Because if we did threading, then that would share resources, meaning client 1 and client 2 on the first game would be sharing the same resources as client 1 and client 2 on the second game, and that would be like sharing the game data between two games, one game's data between two games, and we need to have, you know, two games running and two sets of game data. So yeah, I think to accomplish this we would have to use some processing, multiprocessing, or something like that. But that's gonna involve, just put this at the top and put to do add multi-processing for second, third, etc. game to have same language, i.e. client 1, 2, etc., but have a different set of memory resources apart from game number 1's resources. Yes, so add multiprocessing for second, third, etc. game to have same language, but have different set of memory resources apart from game number 1's resources. Yeah. To have same language, but separate memory pool / execution. So that implies probably that setup this would probably have to be moved. We'll call this multi-process feature below line. Probably, almost certainly. Call would need to be made elsewhere. Would need to be made outside of this block, since we would want it to be run for every new game process. And then the server being server, the server being equal to server. So this creates, okay, the actual server instance. Now, would we need this run as well? I mean, I don't think we would rerun the script, you know? Technically, you know, we could just rerun this script, a different script, which would in and of itself be a different process. But I don't think that's typically the way that you do it. I don't know. Let's consult the wise one. Let's consult the wise ChatGPT, who's actually been making mistakes lately, and I've been noticing that AI has been kind of faltering lately. Let's ask them about if I want to make if I want to convert my online card game in Python um, such that it can handle multiple games being played at one time with various client 1 and client 2s. Currently, it is scaled to handle only one game at a time, or just one game. If you want to convert my online card game in Python such that it can handle multiple games being played at one time with various client 1 and client 2s, would I be able to run another instance of server pi, or would it be more proper to scale server pi to handle multiple clients and have a matchmaking system? Would this be accomplished through multiprocessing? And if so, how would that differ from just running another server script to handle each game? To scale your online card game to handle multiple games and multiple clients concurrently, the best approach would be to modify server pi to handle multiple clients and games within the same instance. Running another server pi for each game is generally not the best solution, as it would result in managing multiple processes which can become inefficient and cumbersome. Well, not actually, because like server itself, well, because server and client are already like packaged. Server is packaged perfectly to handle one game. So like as far as work wise, that would actually be pretty easy. It'd be very easy to just make it to where you can spawn multiple server pi instances. Like you could have, I don't know exactly how that would work, but I'm guessing there would be a way to like basically internally call like another process of server pi itself. Wouldn't that be possible? I don't know. I feel like that's basically the same thing as creating more processes. The only difference is like we would have to modify server pi, as to where the other option we would just multiply the process and not really modify anything. It would just be a brand new server process. It would be a brand new set of clients. The only thing is like how do you trigger that, you know? Like technically yeah, like that doesn't. Well, I'm thinking like if you could like spawn 5 server pies initially, and they're all from the same like address, technically you could have, you know, the first server pi handle the first game, the second one would handle the second, but how, like, how does that happen exactly? You know what I mean? Like, I don't know. This is new territory for me. This is not something I've done before. Now we're getting into the area of multiprocessing, which I've never really done. I've never done this. Um, I feel like this is basically the same thing that I would be doing when I would scale server pi to handle multiple clients. It's almost the exact same thing. It's just, instead of like happening in some like script above server pi, it would be like handled within server pi, if that makes sense. You know, if I could have some like controller script that would, like the server controller, and it would like summon server pi, you know, instances, that would seem to be a, you know, that would work. I think like that would do what I'm trying to do, versus refactoring the entire server pi file to handle a bunch of different connections. I don't know. Let's think about this. So I'll put this in things to do. Let's go over here. Always the things to do list just grows, never gets smaller. It's like the US debt. It never gets smaller, or as soon as it gets smaller, it grows to a larger number immediately after. It's just like a law. It doesn't allow itself to be depleted. So what are we'll call this multi-process server scaling. Implement solution for scaling client capability of server to handle multiple games. Proposed option number 1, controller server, or we'd call it server process controller, and that would having a parent script over server pi to spawn multiple processes of that file to handle each game. And then option number 2 would be server pi scalability refactor. Refactor server pi such that it internally handles more clients. Yeah, so this is theoretically simple, as server pi is already structured to handle 2 clients per script, and this one is theoretically complicated, as it requires adding and modifying existing code and a lot of testing, a lot of risk and testing. Okay, so let's go back over here and see what we got. To scale your online multiple clients with the same. Running on another server pipe for each is generally not the best solution, as it would result in managing multiple processes, which can become inefficient and cumbersome. Here are steps you can follow to handle multiple clients and games with a single server. And server handling you can use asynchronous programming for non-blocking I/O or multi-threading, multi-processing. Yeah, we wouldn't want to use multi-threading. Python's async I/O library or a web framework like Fast API or Flask with asynchronous handling can allow you to manage multiple game sessions and client interactions simultaneously. Python's async I/O library or web framework with Fast API. I always forget what async does. Every time. I forget what async does. Async is... I don't know if async is what we would want to use for this. Because as far as I understand it, async handles... It basically avoids input operation processing time. My big thing is the language we use in server currently. Because don't we need another socket? Another socket per connection. As I look at this, I feel like it would just be smarter to have it just be multiplied, this process, this entire server script, because it wouldn't require a refactor. It's already structured perfectly to handle one game. So like if I'm gonna use multi-processing, why would I not just it's just it's a lot of work. There's a lot of work that I would have to do. Basically all this would have to be changed. Almost everything would have to be changed. because there wouldn't be server client 1 and server client 2. There would be server client 1, 2, 3, 4, 5, 6, you know, however many there were, and we would have to work with a pool of clients, and then we would have to modify almost every single object in this entire script. Like the whole thing would have to be modified. As opposed to just modifying making it to where this process gets spawned. But in that case, like, we wouldn't have pooled matchmaking. Well, that's not entirely true. We could have like a parent script and I don't know, this is going to be really hard. Either way, this is just difficult. Tired as usual. That's life. Always exhausted. It's just the way it is. Oh, fuck, man. This is not easy. This is not gonna be easy. Son of a bitch. Well. I really didn't want to do a complete refactor. I just didn't want to do that. That's not something I have any desire to do whatsoever. But this is the path that I chose. I said I wanted to do this, right? So that's what I have to do. If that's what I have to do, then, well, that's what I have to do. There's not really a way around it. See how they create a new game here? Then they say game equals game, player 1, player 2. You know, that seems so simple to where I could just say all of this happens in the context of one socket, you know, per game. I feel like we would have to use a multi-processing system. I don't think there's a way around that because all of the other files rely on this language. So I don't think there actually is a way around using multiprocessing. If I have a file structure wherein server pi is in terms of client 1 and client 2, which correspond to P1 and P2, and I have a bunch of game logic files that all tie into this 1 and 2 structure. Wouldn't it be basically impossible without an entire project refactor to add in scalability without using multiprocessing? To add in client scalability without using multiprocessing. If your current file structure and game logic are tightly coupled with a one-to-one relationship between client 1 and client 2, scaling the server to handle multiple clients without a significant could be challenging. However, while it would require a redesign of how the server and game logic are structured, you don't necessarily need a complete project refactor. With some effort, you can refactor incrementally, to introduce scalability, and multiprocessing is one way. Well, okay, multiprocessing, yes, not multi-threading. In your case, server pi has tightly coupled logic for managing 2 specific clients. You're likely relying on synchronous communication and direct references to these clients. This makes scaling to handle multiple games and multiple players a bit tricky. Game logic that assumes these 2 clients. This approach works well for one game at a time. It doesn't really allow for multiple games or client management because everything is set up for a one-on-one relationship. Yes. Option for scaling without full refactor. Use multiprocessing to handle multiple games. If a refactor to handle clients asynchronously or through threading feels too difficult, one approach is to use multiprocessing to run separate instances of your game logic in parallel. Each game can run in its own process, with each process handling its own pair of clients. You can spawn a new process for each game. One for client 1 and client 2, another for a different set of players. It can be scaled to handle this method allows you to continue using the existing game logic as is, as each game runs in its own process, avoiding direct conflicts. The complexity of managing multiple processes increases, particularly in coordinating between processes. You also need to manage the life cycle of these processes. When games are over, terminate the processes, etc. Game equals game, player 1, player 2, game start. If name is equal to main. So this is for player 1, player 2, and players. P equals multiprocessing process target run game. Append this to processes and you start the process. So yeah, this is basically like the parent script thing I was talking about, the server controller script. And then you could refactor to use async IO for scalability. If you're open to refactor, the more scalable solution would be to use async IO to handle multiple clients without the need for multiprocessing. I don't understand how async would help me here. I don't really understand how this works. I don't get I don't get it. You change how client connections and game state updates are handled to support non-block I/O. Port async I/O game. Asynchronously waits for player actions, etc. Wait async I/O sleep. I don't understand why async I/O would help. I don't understand how async I/O would help me to. Okay, let me put it this way. But if I need each game session to have its own memory slash references to objects in terms of game dot player 1 dot player 2 dot etc., doesn't this imply I would not be able to use async IO but would rather have to use pure multiprocessing? If each game session requires its own memory space and separate references to objects like game, player 1, player 2, multiprocessing would indeed be more appropriate than async IO. Memory isolation in multiprocessing versus async IO. Async IO operates in a single process with shared memory space. This means that all game sessions, even if they are running concurrently, would share the same memory space, including references to objects. If you need each game to have isolated memory, this could lead to problems because modifications in one game could unintentionally affect others. Yeah, no shit. Async IO is great for IO-bound tasks and concurrency, but not for scenarios where each game needs its own set of objects in memory isolation. Multiprocessing, on the other hand, creates separate processes with their own memory space. Multiprocessing, on the other hand, creates separate processes with their own memory space. Creates separate process with their own memory space. Each game will run its own process with outside memory, meaning each game instance can maintain independent references to player 1 and player 2 without affecting others. This is crucial when you have independent game session running concurrently. Why you would need multiprocessing, independent game logic. I don't necessarily know if I need any inter-process communication. So does each added process require another CPU core? Not really, right? Can't I have 20 processes? Even quad core processor? Duh, that's like, just, yes. Each process doesn't require a separate CPU learning working process on a machine with fewer cores than the number of processes. Here's how it works. Processes and CPU cores. When you create a new process, the operating system schedules it to run on an available CPU core. You don't necessarily need a separate core for each process. The OS will manage multiple processes and allocate CPU time, even if more processes than core. If you have 20 processes, only 4 will divide the available CPU time among these 20 processes. The CPU will context switch between processes rapidly, giving ring simultaneously. This is called time sharing. Context switching. When multiple processes are running on a single core, the operating system switches between them quickly, sometimes times per second. So each process gets a portion of the CPU's time. This is a general purpose technique that allows the system to run many tasks concurrently. There are fewer cores than processes. In a system with more processes than cores. The operating system will try to keep all cores busy, but since each process can only run core at a time, it will share the CPU time. You have a quad-core CPU and 120 processors. All 4 cores will likely be in use at once, and the OS will quickly rotate through those 20 processes. The system may show high CPU utilization even if all cores are not fully utilized because the processes are sharing the available time. These are tasks that require heavy computation like complex game logic, heavy algorithms, etc. When running multiple CPU-bound tasks, more cores can make a difference because each core can work on a separate task. However, if you have more processes than CPU cores, the OS will still manage them by context switching. But the performance may degrade because the CPU will be divided among too many tasks. If the game logic is CPU intensive, complex calculations or simulations, there might be some performance degradation because your 20 processes are competing for the same 4 CPU cores. Your CPU utilization might be near 100% for a while, but each process will get less CPU time compared to running on a machine with more cores. Utilization might be near 100% for a while. Each process will get less CPU time compared to running on a machine with more cores. If the tasks are I/O bound, processor, how many processors per game? For lightweight, you can use 800 or even 1,000 processors on a clock or machine with heading performance bottleneck. Like to be memory if using a lot of memory per process. Or network I/O if you have a network communication between process. If the processes are CPU bound. Okay, gotcha. I understand now. Alright, well, I'm gonna go take a break. I'm gonna go to the gym, and then we'll try to figure out this more, and probably end up using like probably like a parent script sort of thing, like I was proposing, to manage the basically like keep server the same, server pi the same, and then have this like parent controlling script that spawns the processes. And I don't know, man. That's still not going to be easy. I mean, either way is going to be hard. But I honestly am just not up for a complete server refactor. Like I'm just not. I've been working on this project too long. I want nothing to do with an entire server refactor. Like just straight up. Like straight up simple. So anyway, yeah, we'll figure something out.